also a different category of reactions. It's a Mannich reaction. So we'll see stepwise what happened for these reactions. So we have this formaldehyde group, and we know that this is very much reactive. And if we have an amine, NH, secondary amine, so this attach is going to take place. So CO minus, let's do it CH2 NH plus. Then proton exchange. Proton exchange. What type of proton exchange? Intramolecular. It's going to transfer from nitrogen to this oxygen. Intramolecular. OH CH2 N MEM. Now, as we are doing the reactions under acidic conditions, this OH will be protonated. So basically we have OH2 plus CH2 N to methyl. This will go away. CH2 double bond plus. So this is basically enamine, iminian ion. So this is one part that we have generated. Let's see what happens with this part with this moiety. Similarly, now it's a routine type of thinking for us. If we have a carbonyl, let's say cyclohexanol, under acidic conditions, that carbonyl oxide will be protonated and minus H plus will generate an enol. Now this attack will take place. As a result, what we are getting, let's do it from these sides. Basically, we have this OH, we have this also. This is plus. So this is CH2 MEM, OH plus. Basically, just I am doing one step jump because in the next step it will be minus H plus, minus H plus. So this is done. Look, so this is the Mannich reaction. Now we'll see the next step, because in ID JAM or in CSN net, never only one reaction is not asked. That you have been given only Mannich. They have a multi-step reaction. So just we have a we need to have a practice. The what happens after the next step, next step. That's why. So it is a lone pair here. So if we do again one step methylation by methyl iodide by SN2 type reactions, again one methyl will be added to this nitrogen. N. We have 3 methyl group here, double bond O. Now this is highly electron withdrawing, very strong electron withdrawing. We know that quaternary amine is very much strong electron. This is quaternary amine. What we are doing? We are using the base. This proton is acidic. Why? Because This carbon is directly attached to the electronegative carbonyl carbon. That's why this is acidic. So it will be abstracted by base. So basically it is, let's write it down. Here it is SN2 type reaction. Then what is happening? So this negative charge is generated, and we have this quaternary amine, and this negative charge is going to stabilize over the adjacent carbonyl O minus. We have this quaternary amine. We will have this product. So just we learn Mannich, and that's two more steps. So here we found that this is SN2 reactions. Here, as this negative charge is delocalized, and rather this negative charge is responsible for the elimination of this quaternary group, it's a E1 CB type reactions. Also, we identify the different category of reaction in multistep. So the reaction is composed of, first of is a Mannich reaction, up to this is the Mannich reaction, then one SN2 reaction, then one E1 CB eliminations. We have this product. Basically, what we got? We got these things. So if we want to incorporate a double bond just next to the carbonyl group, we have to follow this kind of procedures. Just after Mannich, we need one more methylation. Then we need a elimination reaction which acts to the E1CB mechanism. Next. Similarly, so we have this amine, secondary amine. So in presence of formaldehyde, H plus catalytic amount of, it will generate a iminium ion, N double bond CH2 plus. And what happens? This corresponding aldehyde in presence of H plus also generate a enol. Here all the steps are reversible. Why all the steps are reversible? Later, if we get time, we will discuss some separate sessions. So this is the enol, and we have this iminium ion plus. This will attack here, followed by intramolecular proton transfer, followed by, okay, this is double bond O, this carbon is this CH2, we have this. Now again we are doing one methylations, methyl iodide, so it will proceed by SN2 mechanism. Because of space, I have to remove it or erase it many times. I'm sorry for that. Double bond O in, this is Me. Now in the previous reactions you have seen, if we use a base, it is going to abstract this proton. After that the elimination will take place. Then which minus E1CB eliminations. double bond, sorry, double bond O, and here we will have one double bond. Again, look, we are going to incorporate one double bond here. That's why just Mannich reaction followed by methylation and hydrolysis. Same thing. The last two reaction, what we did here, we have incorporated one double bond here. Also, we have done one double bond here. So same thing, Mannich reaction followed by methylation followed by eliminations. So here just we have used different amine. Again, it is very much important for jam. And now we'll go the next step of reactions. I hope, though I cannot interact directly with the students, but I hope the way we are discussing very slowly. We are just taking care of each and every step. It is totally understandable, visualizable by the students. Next. Okay, let's just compare the stacks. We have a secondary amine, and in presence of H2 and H plus, it will form amine ion CH2 NMe2 plus, and we have this different carbonyl group in presence of H plus. It will form an enol, and this enol will react with this iminian ion OMe OH plus, and here just this is this CH2 and this CH2. Okay, so minus H plus will form this Mannich product, double bond O CH2. Now again we are doing one methylations. It multi-step because the Mannich reaction is a very much important intermediate reactions for multi-step synthesis. That's why we are using or doing Mannich reaction followed by some more step, because we don't need the product just which will be stopped at Mannich stage. We need to go to few more step further. OMe, OMe, double bond O. Now we have this product CH2 in methylations. This is plus SN2. So it is very good living group. Then what will happen? We have used diethyl enolate CO2 ET, CO2 ET. Here we have two proto hydrogen, and it is very much acidic in nature because the negative charge can delocalize. Let's show it here. If we have this group, let's say C double bond O OAT, C double bond O OAT. These are called active methylene group. This is what? Active methylene group. And this proton is very acidic because the negative charge can delocalize, can be stabilized to delocalize over to carbonyl. If this is acidic in nature, then in presence of base, it will be a negative. The in presence of base, what will happen? This will be negative. So here, just to add, we don't have space. That's why now I am directly write it down. It as negative. In presence of base, we have this negative charge. So now this is a good living group. Good living group. And this is a good nucleophile. So this is going to attack here and it is going to leave. So what is the product now? This is OMe double bond O CH2C CO2 ET CO2 ET. This is H. In previous step two reaction, what we have found in previous two reaction, the Mannich reaction followed by elimination. Basically, Mannich reaction followed by methylation and followed by elimination. Here we are seeing the Mannich reaction followed by methylation and followed by substitution. This is the targeted. So what is the A? Basically, A is this product. This is A. What is B? Basically, it should be B. This should be C. This is B, means methylated product, and C, the substituted product. Okay. I think it is enough discussion with respect to this time period for these reactions. Now, again, we will do different kind of things. That's a part of our routine work. H plus CH2 double bond N plus. And what will happen here? We have acetophenol that in presence of proton is going to produce a enol. Now, we have this enol plus we have this iminium ion plus double bond OH plus, and here we have this CH2, one more CH2, this is N. So this is the new carbon-carbon bond formation. And here minus H plus. Basically, it's a reversible step. Double bond O, CH2. Then, instead of methylation, we are doing something different. What is that? So basically, this is our A. We are reducing by NaBH4 because as again I am saying the Mannich reaction is a good intermediate for multi-step synthesis. We can, based on our demand, we can use various type of reagent and we can get various type of product. Double bond O, it will be reduced to alcohol, and this is CH2 and Me2. We are going to use SOCl2, so this will be converted into chloride Me2. Then we have these things. In presence of base, it will from O minus, that O minus is going to replace this Cl. So basically what we have, just I am writing here O, OMe, here. This is the compound which has remarkable applicability in drug development industry, and basically it's sometimes very good potent drug candidate. So that's the message of our reaction. That Mannich reaction will will apply multi-step on the Mannich product. And such type of question is frequently asked in GATE, IT exam, and NET also. Okay, I think using a varieties kind of example on Mannich reaction just will covered sufficiently due time. Again, we have one more very fantastic example. HO in presence of H plus, we will have these things. Okay, now, so this is the indole moiety. Let's draw the structure elaborately. What is happening? It is going to attack through this carbon on this CH2. Indole NH plus CH2 in MEME and plus. In the next step, what will happen? The gain of aromaticity, basically these things, minus H plus. Okay, now basically this is A. If we use Cn minus, if Cn minus is used, if Cn minus acts as base and acts as nucleophile, then we see what will happen. What will happen? Here we have NH. Now Cn minus will act as an base. This will capture this proton and it will go there and this will be eliminated. So what have we got this after treatment with Cn minus? This is very important and interesting reactions. So we have N double bond CH2. This is the product, not the intermediate. Now we have Cn minus. Here we found Cn minus acts as base. Acts as base. Here we'll see Cn minus. Now see the double bond N is corresponding to max carbonyl. That's why it's like alpha beta unsaturated carbonyl. It will attack here. N minus and CH2 Cn. Then protonations. Protonation. NH CH2Cl. So this reaction will proceed only when if Cn minus acts as base as well as nucleophile. It's very interesting reactions. So this is our B.